Today we're going to be looking at linear equations, but we're going to look at them in terms of the form that we state as y equals mx plus c. When we've looked at linear equations, you may have noticed that they all are written in a really similar way. So we've seen ones that look like y equals 2x plus 4, or maybe even y equals negative 3x plus 1. And as you can see with each of these, you've got a coefficient, and then you've also got a constant. So this form of y equals mx plus c describes linear equations. And each of these letters describes something that's really important, especially when graphing linear equations. The y value here is our dependent variable, and that's basically our y-axis. Our x value is our independent variable, and that's on our x-axis. With our equation y equals mx plus c, the m represents something we call the gradient. It's sometimes referred to as the slope, or coefficient, or rate of change. And we write it in the form of rise over run. If it's a whole number, we write it as the whole number over 1. We write it as a fraction. And we're going to go through why in a moment. And lastly, we have our c in our equation, which is known as the constant, or the y-intercept. And that's basically where the line crosses the y-axis on the graph. We can also describe that as when x equals 0. And because of that, we write it in the form of 0, c, or the y value. The gradient really affects what the actual graph looks like. And we're going to go through a few examples now. If we look at our first graph here, we notice that the values, or the slope, is going downwards. And if we look at the equation, we can see the coefficient, or that gradient number, is negative. So we actually describe this as a negative gradient or a negative slope. And we can see that because one of the angle at which the line is at, and it's actually moving downwards, but also the fact that in the equation, the coefficient is a negative number. If we go across to the next one, it looks really similar, but it's angled differently. And we can see that the values are actually going up. And in the equation, the coefficient is positive. So this is a positive slope or a positive gradient. Another type of linear graph is one that we call a horizontal line. And this is where basically the line goes through only the y-axis. So for this particular line, the equation is y equals negative 2, because the line only goes through negative 2 on the y-axis. And we describe this as no change in y values. And lastly, we have a vertical line. And this is where the line only goes through the x-axis. In this example, we write the equation as x equals 1, because the line only goes through 1 on the x-axis. And we describe this as no change in x. So as you can see, we can determine whether the gradient is positive or negative or constant based on not only the description of the graph, but also the equation. In your worksheets, you should have a page that looks like this, where you've got equations and gradients and y-intercept. And what we're going to do is for each of these equations, we're going to find the gradient, and we're also going to find the intercept just by looking at the equation. So as you can see, we have 1, 2, 3, 4, 5 equations. And from the equations, we're going to use the form y equals mx plus c, where m is the gradient, and we're going to write it in the form of rise over run. And we're also going to do c, or the constant, and that is going to be our y-intercept, and we're going to draw it as the form of 0, c value. So let's look at our first equation. The first thing we're going to look at is to find the gradient. And remember, that's that coefficient number. And if we look at this particular equation, y equals 5x plus 4, the coefficient is 5. But I want to write it as a fraction. And with whole numbers, we write it as 5 over 1. So the gradient for this particular equation is 5 over 1. For the y-intercept, this is our constant number. And if we look at our equation here, it's positive 4, and I'm going to write it in the form of an ordered pair. So it's 0, 4, because our y value is always written second. So we're going to do this for each of our equations, and what I might do is just do the gradients first and then go back and do the y-intercepts. So for the second equation, you can see that the coefficient is -3, which means it's a negative gradient, and it's a whole number, so we're going to write it as -3/1. Equation 3 is y equals 4/3x minus 2. So the gradient's already written in the form of rise over run, so it's 4/3. Equation 4, y equals 2x. As you can see, the coefficient is 2. It's a whole number, so we're going to write it as rise over run, so 2/1. And lastly, as you can see, there is no coefficient here. There is no coefficient to x. So the gradient for this particular equation is just 0. So just by looking at these equations, I was able to get the gradient. And this is important when graphing linear equations. Now we're going to go through each of the equations and find the y-intercept. So if we have a look at equation 2, y equals -3x minus 2. The constant is -2. So we're going to write it as 0, -2. With both the gradient as well as the y-intercept, it's important to include negative numbers. So equation 3, y equals 4/3x minus 2. My y-intercept is -2 again, so it's 0, -2. Equation 4, y equals 2x. As you can see, there is no constant. So this particular y-intercept is just 0, 0. And this is the origin, or the point where the y and the x-axes meet, and it's that middle point. Lastly, equation 5, y equals 3, which is just the constant, so we write that as 0, 3. So as you can see, from just the linear equations, I was able to find the gradient as well as the y-intercept. And these are important for when we're graphing linear equations, and it saves us from creating a table of values to be able to draw them. The following are the steps that we use for graphing linear equations using gradients and y-intercepts. The first step is to plot the y-intercept. So if you remember our form again, mx plus c, we look at our equation and we plot the y-intercept first. We're then going to go through and use the gradient to plot our second point. So the top number tells us from the gradient how much we need to move up or down, and then our bottom number, denominator, tells us how much we need to move across. And then we're going to plot a second point. And then after that, we're then going to join those two coordinates by a line, and we should be able to then get a linear graph. The equation that we're looking at is y equals 5x plus 4. So if you remember our equation, y equals mx plus c, the m, or the coefficient, tells us the gradient, which is 5/1. And that's written in the form of rise over run. The next point that we've got to try and find from our equation is the y-intercept, and that is this constant here. And remember, we're going to write that as 0, 4. So if we remember our steps, which is 1, plot the y-intercept, and then place a coordinate after we've applied the gradient, then the first thing we're going to do is plot our y-intercept. And that is the point of +4, 0 and +4, which is the point of going through the y-axis. So I've done that there. There's my first point. The next thing I'm going to do now is I'm going to put in place the gradient. And this is where it's important that we write it in rise over run. So the top number, which is 5, means to rise by 5 points. So 1, 2, 3, 4, 5. So I have gone up by 5. The bottom number tells me I've got to run across 1. So I go 1, and here is my second point. So I've gone across 1, and I've gone up by 5. So rise over run. So that's where the gradient comes into play. It tells me how to, from my y-intercept, how many points to go up, and then how many points to go across to get my second coordinate. The last thing I'm going to do now is to join these two coordinates. to give us a straight line. So remember, when you're doing it yourself, please use a ruler, and I'm going to try again to do it as accurate as I can on my computer. So we're going to try and join up these 2 points in a straight line. Let me see if I can try that one more time. So what you want to be able to do is go through those 2 points and join them. So we've used the form of y equals mx plus c to find the gradient as well as the y-intercept to be able to draw a linear graph. The other thing that you can do using the form of y equals mx plus c is to find the equation by looking at the graph. So the first thing we're going to do is find the gradient. And here, as you can see, we've got 2 coordinates that we can actually try and find the rise and the run. So what I'm going to do first is I'm going to just draw a line and join up these 2 coordinates. So as you can see, rise over run. And that is the form that I want to write my gradient or my coefficient. So as you can see, we're going to count to see how much it's rose by. So 1, 2, 3, 4. So we're actually going to rise by 4. And we're going to see how much it runs across by. 1, 2, 3, 4, 5, 6. And we can actually simplify that to 2 over 3. The other thing I want to check before I move on from the gradient is whether it's positive or negative. And as you can see, the values actually are going down. So this is a negative gradient. So if we look at our equation, it's actually minus 2 over 3x for my first value of my equation. The second thing that we're going to look at is the y-intercept, and that's going to give us the second part of our equation. So we've got this part, so the part where the linear graph goes through the y-axis. So if you have a look here, we were at 0 and it goes through positive 1. So in terms of our c value, it's plus 1. So as you can see, from our graph, I was able to get the rise over run, which gives me my gradient, and also the fact that its values are going downwards tells us it's negative, which then gives us our coefficient. The y-intercept then gives me the constant for the equation. So by looking at the graph, we are now able to find the linear equation.